Okay, let's give you guys a polar coordinates question. So I've got a circle of radius 2, and I'm going to draw a straight line here at 45 degrees. Work out this area here. So use polar coordinates. So convert this into polar coordinates and then integrate it using polar coordinates. Okay, so press pause and have a go. Okay, so first step is to convert this into polar coordinates. So let's multiply this out. Multiply this out. That will then give us this thing here. That will then give us this thing here. So when you're trying to convert from Cartesian into polar form, always keep an eye out for x squared plus y squared. Here you've got x squared plus y squared. So you can put r squared into here. You can put r squared into here. So here you can put r squared into here. By the way, these two 4's, they cancel each other out. And then looking at the y, put this into the y. That will then take us to here. That will then take us to here. And then to draw that circle, you need to impose this. You need to demand that this whole thing here equals 0. Well, demanding that this whole thing here equals 0 is the same as you demanding that the radius be 0 or this to be 0. But the radius of 0 is meaningless in our case. A circle of radius 0 is useless in our case. So we are going to use this. Making this demand is the same as you making this demand. So this thing here will draw a circle for you in polar form. So in polar form, this circle is given by this. So what that means is when the angle is 0, the radius will be 0. When the angle is whatever here, when you put it into here, the radius will be this length here. So when the angle is this much, then when you put this angle into here, then the whole thing here will be the radius, will be this radius here. So the radius of the circle, the equation of the circle in polar form is given by this. So now to work out the area, remember we are integrating from an angle of 0 to pi over 4. So we are integrating it from 0 to pi over 4, which is 45 degrees. Looking at the r, we need to put this into the r here. So this is our r here, and then we need to square it. And we need to integrate it with respect to the angle. So this area here is given by this thing here. Okay. By the way, we've done this before, so I'm expecting you to know that the area in polar form is given by this. Well, anyway, we are currently at this stage. So now it's just a matter of integrating it. So hang on. So this thing here means this. Squared means this thing here. So take out the 16. That will then give you this thing here, and then we can just concentrate on integrating sine squared. Remember, to integrate sine squared, you need to know this. To integrate sine squared, we are going to put this into the sine squared, into here. So this thing here is the same as this thing here. So this is a constant, so we can take it out. That will then become 4. And then this is slightly easier to integrate now. So integrate that, it will then be, integrate 1, that with respect to theta, that will then be theta. Integrate this will then give you this whole thing here. And then now we need to put pi over 4 into here. That will then give us this. Put pi over 4 into here. That will then give us this thing here. By the way, this is sine pi over 2. Okay, it's the same as pi over 2. And then take away, and then put this 0 into here. That will then give us this. And put 0 into here. 0 times 2, it will be 0. Sine of 0 is 0, so it will give you 0. So it's just a matter of tidying this thing up. This block here, well, if you look at the sine graph, it looks like this. 2 pi, 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 hang on, let me think. This thing here is pi. This thing here is pi. I made a mistake here. It should be pi over 2 here. And this thing here is pi over 2. This thing here is pi over 2. So sine pi over 2 is actually 1. So this block here is the number 1. This block here is the number 1. So we can put 1 into this block. That will then become a half. So now times top and bottom here by 2, so that would become pi take away 2 over 4. These two 4's cancel each other out. So the area is given by pi minus 2. So this area here is pi minus 2. Okay.